Welcome back. My name is Travis Lenz, an applications engineer at Skyworks. And last time we took a look at how to get started with the SI83XX SPI motherboard. This time we're going to take a look at how to use the Skyworks Industrial I/O control panel to interface with our motherboard and daughter cards. So let's get started. Here I have an SI83XX SPI motherboard with a single SI834X daughter card attached. This time I've connected 4 solenoids to the output channels just to function as an inductive load. I'm also going to add these 2 additional daughter cards to the stack, with the bottom one being an 834X daughter card and the top one being an SI838X daughter card. They're connected in a loopback configuration just to demo both devices at the same time. Remember that you can connect up to 4 daughter cards at a time, so you can interface with up to 32 input channels or 16 output channels or some combination thereof. Just remember, if you do mix daughter cards, the SI838X daughter card needs to go on top. I've also got a few scope probes attached right now, just so we can see the input and output waveforms on our oscilloscope. Next, I'll get the cables plugged in and load up the GUI so we can demo the stack. Once the GUI is loaded, our first step is going to be to connect the motherboard. So to do that, we're going to go to our VCP device drop-down list and find our microcontroller. Once you've connected, you should see the devices populate in the GUI, which is a good sign. And anytime you're using brand new hardware out of the box, I recommend using the built-in test procedure in our GUI just to make sure that all the channels are toggling and all of our hardware is functioning properly. So to do that, you'll go to the Quick Start menu and click on Test Program, which will open a new window. Now going through the test program, it's going to ask you to verify that some channels are toggling and different LEDs are turning on. And it does take a few minutes, so to save us some time, I'm going to speed through it really quickly and I'll see you on the other side. Once our test procedure is complete, we're ready to start configuring our devices and move on with our demonstration. Let's take a closer look at our SI834X widget. On the left side, we have our channel output control, which allows us to toggle the output channels when the OE button is enabled. And the OE button is in the bottom right corner of the GUI, so once turning that on, I can enable and disable my output channels. In the middle is our fault control. And on the leftmost column of fault control is our fault enable buttons. So these actually let us enable different fault types to be pulled out on the fault pin. So disabling these does not actually disable the fault condition. It just determines whether or not that fault shows up on the output pin. For example, I've got an open circuit warning on device 1 here. And if I enable this fault enable button, it should pull this fault out onto my system fault pin, which is also located in the bottom right corner of my motherboard status. So turning that off should disable that fault as well. The middle column here is our auto clear enable column, and this basically will auto clear the fault bits in the fault register once the fault condition is removed. So if I plug my output channels back into device 1, I should see those faults disappear, and that's exactly what happens. Now if I disable this button and reapply the fault, you'll notice that the fault bits remain in the fault register. So that'll force me to use the manual clear button in my third column to get rid of them. Over to the right side of my widget is my register map, which gives me each of my device register addresses and names, as well as the current data that's stored in that register at this time. Next, let's take a look at our SI838X device widget. At the top, we have grouped channel control for both of my debounce delay and debounce mode settings. So I can change those settings for all 8 channels simultaneously by clicking on the different options here. On the bottom half, I have input channel status, which is going to tell us when we have 24 volts applied to my different input channels. Just below that, I've got drop downs to control debounce mode and delay for each of my individual channels. But in order to enable those options, I need to click on these checkboxes up at the top. This allows me to choose different options for each of my input channels. Off to the right, we also have the register map for the 838X devices, which provides me with each of the register addresses and names, as well as the data that's currently stored in those registers. Next, let's conduct a brief demo of our 834X and 838X daughter cards in operation. So recall that I've got device 0 connected to these 4 solenoids just to function as an inductive load, and I've got devices 1 and 2 connected in a loopback configuration. I've got channels 1 and 2 of my oscilloscope connected to device 0 outputs, and then I've got channels 3 and 4 connected to my device 2 inputs. So in order to toggle all of my output channels simultaneously, I'm going to turn on the OE button to enable all of my outputs, and then I'm just going to turn on each of my output channels for devices 0 and device 1. From here, I can just use the OE button to turn all of my channels off and on simultaneously. You'll notice with the 834X outputs that you can actually see the multi-voltage clamp in operation. That's going to conclude our brief demonstration of the SI83XX SPI motherboard and daughter cards. For more information, visit the SPI motherboard portfolio page where you can find UG459 and AppNote 1382. Thanks for tuning in.